Chapter 1: Data Representation. In this chapter, we will explore the fundamental purpose of statistics. Statistics primarily involves collecting, organizing, and then interpreting data in order to draw conclusions or make decisions based on that data. This task is often made easier if we are able to create a clear picture or story from the data, as opposed to only staring at a page full of observations without context or conclusion. This chapter seeks to introduce ways in which data can be organized in order to create such a picture or story, which would enable us to understand the behavior of the experiment or phenomenon being studied. It would be beneficial to define some very important terms now, which will be used throughout the text. Random variable. This is the outcome of an experiment that is as yet unknown. For example, if we were to roll a six-sided die once, our random variable would be the outcome of the roll before we actually roll the die. We may know what the possible outcomes of the experiment could be beforehand, 1, 2, 3, 4, 5, or 6. But at the outset of the experiment, we don't know which of these possible outcomes would actually occur in future. Sample space. This is the set of all possible outcomes of our experiment. In our example, the die could obtain any one of the following results: 1, 2, 3, 4, 5, or 6. The set S is called the sample space and is usually denoted by the full set of possible outcomes of our experiment written in curly brackets. Qualitative data. This is data that is non-numeric in nature. For example, a customer satisfaction survey could ask the question, "How was our service?" The questionnaire could then provide a customer with the options good, bad, or average. These options, good, bad, or average, are non-numeric. Note, even if we were to analyze all the questionnaires that were filled in, it would not be possible to obtain any meaningful mathematical measurements from the words good, average, or bad. We would somehow need to convert this qualitative data into a numerical format which could be further analyzed. Quantitative data. This is data that takes on numeric values. For example, the length of a piece of string, or the number of buildings in a town, and so on. For the remainder of the syllabus, we will focus primarily on quantitative data. We will learn mathematical techniques that will enable us to organize and analyze such data in order to be able to make meaningful judgments and conclusions thereon. When data is quantitative, our random variables can either be discrete or continuous. Discrete random variables. These are random variables where the sample space can only contain integer values. In other words, only positive or negative whole numbers ranging from negative infinity to positive infinity. For example, if the random variable being studied was the number of customers in a cinema during a specific showtime, the possible outcomes of this random variable could only be 0, 1, 2, 3, 4, etc., all the way up to 300, assuming the cinema contained 300 seats. It is clear that our random variable cannot take on non-integer values such as 3.345 or 0.2, and so on. The number of customers must be a whole number. Another example could be the inventory of silver bars actually kept in a vault owned by a silver exchange-traded fund. Assuming that the fund could take deposits from investors without having to hold the exact amount of silver equal to the value of those deposits, the fund could theoretically run a deficit whereby it owes silver to the investors, or a surplus where it has more silver on hand than actual deposits from investors. So here, the net silver position in bars could take on any negative or positive whole number theoretically, assuming silver bars are not divisible. The net position or number of silver bars held must be an integer, not a non-integer. Continuous random variables. These are random variables where the outcomes can take on any value on the real number line. For example, suppose our random variable was the actual distance traveled by a courier working for a logistics company. The distance traveled could take on values of 60 kilometers or 80 kilometers per day, but it could also take on values such as 73.4738 kilometers, for example. The following schematic summarizes what we have just covered, illustrating how all of the above concepts are linked. Statistics can be broken down into qualitative or quantitative data, and quantitative data can be further broken down into either discrete random variables or continuous random variables. Now that we've covered the basic terms and concepts, we can now move on to the main purpose of this chapter, the visual representation of data.